and the formulas. In Jesus' name of prayer. Amen.
Amen. Thank you, Lucinda. Okay, anyone to read for us number 1 of the questions that were sent on the Google Classroom? I will share my whiteboard. Girls, were we able to access the questions that were posted over the weekend?
No.
No, teacher.
Yes. No.
Teacher, were there about ratios?
Yes, there were.
So then we got them. I got them.
So were there notes?
No, it was a photo which had ratio questions.
So yes, we got them. I was just asking about like ratios. Has there ever been a sending of the notes? Because I've not seen them.
Yes, I think Mr. Matumbe posted it.
Teacher, are we supposed to write them in our books? The numbers.
Yes, please. You are supposed to write them in your books and try them out over the weekend.
Mr. Bato, can you please make me a host, a co-host? Mr. Bato?
Matumbe, good morning.
Good morning, Mr. Sekaita.
Kulika yo.
One to me, one, Mr. Sekaita.
Oh,
Mr. Bato, are you there, please?
He's coming.
Okay, so I think I can start. A little here. A second. I don't know whether my body is seen now. Now that I'm not a co-host.
Yeah, we can see it. We can see it.
Okay,
we can see the board. We can see the brown man standing for the board somewhere.
Okay. Okay.
Tukulaba bulungi oyeruse n'okwetuka kamera ekwongeddemu.
Like the way. Okay. Good morning, everyone. I hope we are very, very fine. Teacher Martha, did you okay about the prayer?
Yes, we did.
You did, okay. So that is very fine. Eh? I want to pick it exactly from where we stopped on Wednesday last week. We did the sharing and everyone is now comfortable with the sharing. That's very good. I want us to look at the increase and decrease in a given ratio first. Then later, if time allows, we shall see what to add on. So right now, it is increase and decrease in a given ratio. The subheading is increase and decrease. Okay, so it is increase and decrease. Increase and decrease. Okay. Increase and decrease in a given ratio. That's what I want us to look at first. And straight we shall go to an example. Example 1. Example 1. We are told to increase Example 1, increase 40 kilograms, increase 40 kilograms.
Excuse me, sir.
In the ratio.
So is this the work that was in the Google Classroom that we're supposed to do?
5 to 4. Okay.
No.
Increase 40 kilograms in the ratio 5 to 4. That's where we are. I'm very sure and convinced that you looked at this increase and decrease in P5. Okay, if you went to a good school, and I know all of you went to good schools. So increasing and decreasing, you looked at those two in around P5, P6. Me who went to a certain school somewhere, we covered these things in P2. Okay. So who can I move with here? Increase 40 kilograms in the ratio 5 to 4. Who can I move with?
Where is Zora?
There is.
Zora's hand is up.
Zora?
Yes.
Okay. Increase 40 kilograms in the ratio 5 to 4. How do we go about that?
So to increase this number, it's 40 times the larger ratio out of the smaller ratio, which is 5 out of 4.
Okay, so it is larger divided by the smaller times the value that you are increasing.
Yes.
What you are getting is the new value. So we come and say that new value is equal to, you have said that since we are increasing, we say larger ratio divided by the smaller. Very good. So the larger one here is 5 out of 4 times what we are increasing, which is the 40 kilograms. So what are we going to have here?
5
by
times
4,
10.
By 4, 1. By 4 here?
10.
Okay. So what do we have? 5 times
50. 10, which is equal to 50 kilograms.
50 kilograms. Don't forget the units, if they are there. Here you are given kilograms, so the answer must be in kilograms. So our increased value, I think you have to use that when than the old value because you are increasing. Okay, so that is it. That is it. If there is a question, please ask. Increasing in a given ratio. Larger divided by smaller times times what you are increasing.
So it has to be, since we're increasing, it has to be the bigger ratio, or it doesn't.
I beg your pardon?
Saying that since we're increasing, we put the larger ratio as the numerator, the fraction.
Yes.
Okay.
Then times divided by the smaller times what you are increasing.
Excuse me, teacher.
Okay, thank you.
Yes, someone is excused.
Teacher, can we increase or decrease to 3 ratios?
Can we?
Can we increase or decrease to 3 ratios?
Can we increase?
Teacher, can they give us a ratio, maybe 5 to 4 to 2, and they ask us to increase?
No, that one is not there. There will be 2 ratios, There will be 2 ratios and increasing larger out of the smaller times the value that you are increasing. So I hope that is very fine for everyone. Okay. Teacher Martha, there is no any other question.
I don't see any hands up.
Okay, so that means that people have understood it. Eh?
Hopefully.
Yeah, very simple. Some of us covered these things in P2. We are here in secondary repeating the same. So that is very fine. That is very fine. We go to the example 2. Okay. Example 2. Decrease. Example 2. Example 2. Decrease. Decrease. Shillings 24,000. 24,000 in the ratio 5:8. Decrease 24,000 shillings
Can I
in the
give,
ratio 5. Yes.
can I give the answer?
Who is that one?
That's Dove.
That is Dab. Okay, yeah, Dab is very okay.
I think it's 15,000 shilling.
You think it is?
15,000.
You are giving me the final answer. No,
Outside,
give the word to
since we are decreasing, we put the smaller ratio on the numerator side and the bigger ratio on the denominator side, and then multiply by the number or shillings, okay, the money given. And then when you multiply 24 divided by 8 will be 3,000. And then when you multiply it by the 5, it will become 15,000 shillings. Did you get it?
Yes, I've got it, but I want us to go step by step. Eh? New value. New value will do what here?
The new value will be 5/8 times 24,000.
5 out of 8 times the 24,000. So the point here in decreasing will be smaller value divided by the larger value times what you are decreasing. So when you simplify this, you get shillings.
15,000.
15,000. And this new value must be smaller than what you started with because we are decreasing. Is that okay, people?
Yes, teacher.
Dav, thank you. Okay. So that is how we decrease. Is there any question?
There is Daniela's hand.
Daniela Akero.
Akero.
Yeah. Good morning, teacher.
Good morning, Daniela.
So as we are learning under this subtopic, would we look at working with decimals?
Working with the decimals?
Yes.
In most cases, when we are setting these questions, we first calculate it and see. And in most cases, we want to avoid decimals. But if it is set and it's giving you decimals here, you write it. You put the decimals there. To
Okay,
see decimal places like this.
Okay, teacher, what if the main number, like say 24,000, would be replaced with a decimal?
If the main number, the 24,000, is replaced with a decimal.
Yes. Well, what would we do then? Are we going to look at that in a later stage?
No, any number, whether decimal or not a decimal, can be given. And the answer can be a decimal or a whole number. It doesn't give us changed something there. You see what I've written? Is that okay? Daniel, are you there?
Yes.
So we are decreasing. What will the new value be?
So we'd have 2 out of 8 times 10,000. Sorry, 2 out of 3 times 10,000.
So what do we have? So what is the answer?
What if we use an unknown? Like
No. Let us what the first question is first. Let us what is the answer?
667.
667.
667.
60. There's a 6, there's a 6, there's a 6.
6.666.
66. What is it?
it's recurring.
It is recurring. Is that okay? Is that okay?
Yes.
So, now let me ask the first question. Is your mathematics correct?
Excuse me, I didn't hear that. Can you please repeat?
Yes. You're muted.
You're muted. Miss, you're muted.
Okay.
We can't hear you.
Okay. I hope we are fine now.
Oh, we are okay now. We can hear you, Ma'am Senjobe. Thank you.
So I'm asking, is your mathematics correct?
Yes.
But what value have you got?
A decimal.
So how would you write this decimal if you don't want to write a decimal?
Round off.
Is that okay? You have a mixed what? Or you can write it as the way I did it. So how do you handle such numbers? What would you do?
You round off.
This mode, you round off. Is that okay? So you just round off to the nearest, if you want, to the nearest whole number, and you are still correct. So at this is possible, they are possible as long as the mathematics is correct.
Excuse me, teacher.
Yes, please.
Would it still be okay if you use the method of an unknown? Like, let's say x is the new value, and then you do the x is equal to the 2/3 times 10, and then
X is equal to 2/3.
Like if a new value is equal to x, and then you use x is equal to 2/3 times 10, and then we get rid of the denominator like that.
2/3 times
10, and then you multiply the 3 on both sides of the equal signs. And then we get, like, you multiply by x, that's okay, the denominator 3 by x, and then the denominator 3 by the 2/3.
But why are you suffering?
I'm just asking.
Wait, this time you can evaluate x later. Why are we suffering? These are correct numbers. You just evaluate x.
Just asking if it was correct, because It still gets the
It
same
is
answer.
wrong. It is wrong because already X has been made the subject. So you can only evaluate it. You
Teacher,
cannot
no,
find it
I
by
want
any other method.
like that, teacher. I meant what if I meant what if we take the new value as X? Okay, like we make it an unknown.
Yes.
Yes. And then
Yes.
we use the method the way we're doing it, and then in the end we divide by 3 on both sides to get the unknown in the end.
We divide by 3 on both sides.
No, teacher, let's first go through it and
you have already made X the subject. There is no other way of solving that X apart from solving. It is very simple.
Thank you, teacher.
Kista also has a question. Kista.
Teacher, can they tell us to decrease?
Who was that one?
Teacher, it's Kisa.
Who was that one asking?
It's me.
Can
they tell us to decrease or increase a value to like an even ratio?
Asking this.
It was Dav. It was Dav, me, teacher.
Yeah, Dav. Your answer will be correct, and your working has nothing wrong, but it's like you are in your stream senior 2D. They tell you to go to say administration block, and then you first go to Rhoda, then you come to the physics lab, and then you go to the administration block. Yes, you have reached there, but while first going there, come back, go there, yes, and then come back to the same thing. Yes. So Dav, your work will be correct, but you look a confused person, eh? Yes, you go straight by this thing. Then now you let the new value be X. You say X is equal to this one, which is very okay. And then you multiply the two sides by 3. Again later you have to divide the two sides by 3. You look confused. Are you seeing that? Eh?
Yes, teacher, thank you.
Yeah, you get the marks, but now
I have a
the teacher will be like, what's wrong with this girl? Okay, that is fine. Is there any other person with a question?
There is Paula. Kazina. Paula Kazina.
So yes, I was asking. I got off the lesson, so I never really understood this last number you were explaining. Why exactly can't you do it like all the other numbers?
Like the which numbers?
Like how we're doing the first 2 numbers.
What did I do? In the decrease, I have said that the working is very simple. It is smaller value, smaller ratio divided by the larger ratio times what you are told to decrease.
No, sir, I was saying something about X.
Yes?
I was saying something about X and then...
No, that was another person's suggestion. That was another person's working. Eh? But the direct working is smaller ratio divided by the larger times what you are told to decrease. That's very simple, and that is it. Eh?
Okay, thank you, sir.
You are welcome. Another person, if there is another person with a question. Mr. Sagaita, is there any other hand?
There is Rohana.
What is she saying?
Teacher, the formula for doing increase and decrease are the same. What if they ask you to decrease something and you end up increasing it?
What if they tell you
to decrease something and you end up increasing it?
Then you have not answered the question.
that would be a different question, and setting your own question won't earn you any mark. So if I tell you to increase and you instead decrease, I mean, we don't give you any mark there. I hope I have answered you. Is there another person? Okay, I think we have exhausted this one. Okay, and that is very good. The last question here. Someone here is saying, this is example 3. Someone is saying, increase the size of a rectangle. Increase the size of a rectangle, measuring 18 centimeters by 12 centimeters in the ratio in the ratio 5 to 2. In the ratio 5 to 2. And then continuation. What is the ratio? What is the ratio of what is the ratio of? There is a Roman here. Old perimeter. Old perimeter to new perimeter. Roman 2 here. Old area to new area. Okay, so that's where we are.
Teacher, can I try going through this?
You want
Yes, I want to try,
to
teacher.
to increase?
Okay, yeah, no,
Who is
I
that
wanted.
one?
It's Dav.
Hey, Dav again. Dav.
Yes, teacher.
Shona can also try. Yeah,
Yeah, can I first give this chance to another person?
Shona, yes.
Yes.
So I'll try Roman 1 that say to increase the size of a rectangle, measuring 18 centimeters by 12 centimeters in the ratio 5 to 2. So I think first find the perimeter of the first of 18 and 12, I think. Yeah.
Before we get to this one, they told us to increase the size of a rectangle, measuring this by this in this ratio. Before we come to these 2 Romans, let's first do up to here.
Oh, okay, so I think maybe we get 18 times 5, then 12 times 2. To get.
I beg your pardon?
I think that we get the 18 times 5 and then the 12 times 2.
Teacher.
Was that in Dagire?
Yes.
You want us to multiply this 18 by 5, then divide by 12.
No, teacher, then the 2 times the 12. Yeah.
Okay, thank you. But
Excuse me, teacher.
each side here is independent, I think.
The perimeter before you find the ratio, the increased ratio. What if you first find the perimeter, which was like 60 centimeters, and then you multiply it by that ratio and increase it. Then you divide by 4.
Then you divide by 4.
Okay, so no. See, what if you first find the perimeter, which is length plus width plus length plus width, which you'll get in the end 60 centimeters. And then you 60 centimeters, you you get 5/2 times 60 centimeters. And then after you get the increased ratio, you divide it by 4, right? Find the increased
Why dividing
size.
it by 4? Why
That you
dividing
can
it by
find.
Why
Because
dividing it by
that you can find the increased sides of the rectangle. That you can find each. Wait, sorry, teacher, I've forgotten, confused there. But if you are to find the increased sides of the rectangle, you to find a way to divide the 60 centimeters by those 4 sides. I think I'm not very sure, teacher.
Is that dove?
Yeah, yes.
It's not very clear, and you have also said it that you are confused somewhere, so it's not very clear.
Yes, teacher, it's not very clear. It was just my trial.
Okay, thank you. Can we get another person? Thank you, Dave. Are we seeing the question?
Excuse me, teacher, can I try?
Who is that one? You tell me your name.
Amelia Nadunga.
Okay,
Teacher,
Amelia.
Just get the side 18 centimeters and we multiply like 5/2, and then 12 centimeters times 5/2, and we increase both of them.
That is increasing each side. That will be a very good step. So, Amelia, we are here. You have said the new length. New length will be
18 centimeters times okay, 5/2 times centimeters.
And this one will give us
45.
Amelia, this one will give us 45.
45.
Okay.
Other side.
Then we go to new width. The new width will be
5/2 times 12 centimeters.
5/2 times 12 centimeters. And this will give us
30.
30.
That will be 30 centimeters.
Yes.
Okay, that is very good, Amelia. Then we come to this. What is the ratio of old perimeter to new perimeter? Amelia, are you still there?
Yes, teacher.
What is the ratio of old perimeter to new perimeter?
We find the perimeter, the old perimeter, whose length was 18 centimeters and width was 12 centimeters. We find perimeter is equal to plus 2 width.
We find the old perimeter.
And then we find
the old perimeter will be what? What is the formula for getting the perimeter of a rectangle?
2 into length plus width.
You are saying it is the 2
into length plus width.
2 length plus 2 width.
Okay, so the old one will be
60.
bracket 8 12.
18 plus 12.
Amelia, you are breaking. Can you get okay? One person at a go. Amelia, we are with you.
Can you hear me now?
Yes, though a little breaking, but okay, fine. We can bear with it.
Another person do it because I'm breaking right now.
I tell you, you are now clear.
Now, okay. 18 plus 12 to give us 30.
Okay, 18 plus 12 to give us 2
That
times
is 6.
And this will be 60 centimeters.
As the old perimeter. Then the new perimeter will be 2 into brackets 5 centimeters plus 30 centimeters.
45 plus 30. Okay.
72 into bracket 70 centimeters. 75.
This is?
Can you hear?
Yes, I can hear you.
Excuse me, sir.
I can hear you with the difficulty now.
Sir, I haven't really understood this. Can you please do another one?
Which one haven't you understood?
So I never copied the question, so like I don't know what you're doing.
Where were you when the others were copying the question?
So I didn't know anyone was copying the question, sir. Mr. Sir,
but I gave you time to copy the question.
Oh, Mr. Sir, please.
Okay.
Thank you, sir.
Mary, are you still there?
Answer is 150.
The answer is
150.
Yes, teacher. 150
centimeters. So the question was to get the ratio of the old perimeter to the new perimeter.
Yes.
So how do I?
To be 60 to 150.
Meters out of 50. Old perimeter out of the new perimeter.
Old perimeter to new perimeter would be, tell me.
60 centimeters out of 150 centimeters.
60 centimeters. You want to say out of 150 centimeters. We want to reduce.
Pardon?
We want to reduce this.
Yes, we use divide by 3 to
by
2.
By 3 here.
And then by 3.
By 3 here, Amelia.
5.
Okay. So do we have any other number that can divide the 2 and 5?
No.
So we conclude that the ratio is
no. 2
to
5
to 5. That is very good. So the ratio is 2 to 5. I can talk about the steps.
I'm excuse me, teacher.
Thank you, Amelia. Someone who didn't copy the question. The question was increase the size of a rectangle measuring 18 centimeters by 12 centimeters in the ratio of 5 to 2.
Mr. Sir, I can't write that first.
No, I'm not telling you to write. Your time for writing expired. So I'm now taking you through the question.
Okay, Mr. Sir.
That's Mr. Sir. My name is Kennedy Matumbwe. I'm not a sir. Okay.
Okay.
Yeah, so we are saying the person who asked that the question is increase the sides of a rectangle measuring 18 centimeters by 12 centimeters in the ratio 5 to 2. That was the first step. So we increased the length, which is 18, in the ratio 5 to 2, which will be 5 out of 2 times that 18. And we got to 45 as the new length. We increased the width, which is 12, in the ratio 5 to 2. So the new width became 5 out of 2 times 12, and we got 30 as the new width. That was the first part.
So that's all you have to do.
Now, this part that you are seeing here, we are told to find the ratio of old perimeter to new perimeter. Okay, and the steps are here. We got the old perimeter as this one. We're using the old dimensions, and we got the old perimeter as this one. The new perimeter is this when we are using the new dimensions, the new length and the new width, and we got it as 150. Now, the ratio of old perimeter to new perimeter is 60 out of 50. Remember, is 60 out of 150. Remember, we said that a ratio is a fraction. So the old perimeter to new perimeter, I can write it as 60, which is the old value, divided by the 150, which is the new value. I reduce here and get 2 out of 5, which is written as 2 to 5. So that is the ratio of old perimeter to new perimeter.
Excuse me, teacher.
I hope, yes.
Excuse me, teacher. Chat, if you use another method.
Which method is
like,
that one?
First find the general perimeter without increasing anything, which is 60. Then you increase the perimeter to 5 to 2, which is 150, and then you get the ratio of old to new.
Okay, it's very fine. It's very fine. Okay. It's very fine. Because perimeter is linear and length is also, length and width are also linear. But it won't work for the area. That one won't work for the area. But for the perimeter, since it is linear in centimeter and linear here in centimeter, then it will work. It will be very fine. Okay? Kainembabazi.
Teacher, could you please explain how you got the new perimeter?
Okay, I got the new perimeter using the new dimensions. Remember, I increased length to get the new length. I increased the width to get the new width. Now, the new perimeter of the rectangle will be obtained when you have used those new dimensions, the new length and the new width.
Teacher, can you just increase the old perimeter?
Can I what?
Just increase the old perimeter.
Yeah, I said it's okay with perimeter. That's what I have just explained. That for perimeter, it's very okay because perimeter is linear units, centimeters, and length and width are also linear. So it will be very fine. But for area, it won't work area, you can't increase the old area to get the new area using the same ratio. Because area is in square units.
Mama Tumbwe?
Yes, sir.
Ntongo has a question also.
Teacher.
Yes, teacher. Teacher was asking, when teacher, the length and width, which one is longer?
Length and width.
Yes, teacher.
Okay, normally length is longer, but we can't stick to that one. That is minor. But normally length is longer than width. Eh?
Teacher, so if we do the way you did, like if we mix them up in the paper, that is.
If we do, Ntonga, I beg your pardon?
Teacher, if we mix them up in the paper, we don't lose marks, it's okay.
It's okay because they didn't mention that this is length, the other one is width. And we get to the same answer.
Teacher, I thought if you mix them up, you lose marks, but it's okay.
You do what?
Teacher, it's okay.
Yeah, I said normally length is longer than width, but it's not something that is major. It's very minor. So if they have not told you that this is length, the other one is width, you do. I mean, it will be your choice.
Teacher.
So the questions are over.
Keynes hand is still up. Keynes Babazi?
Teacher, from the question I had asked you before, are you saying that you increased them? You increased 18 and 12 by the ratio to get the new perimeter?
You increase each one independently to get the new dimensions. And the new dimensions will give you the new perimeter. That's what we have done. Is that okay?
Yes.
Okay, that's very good. Now, the second part, we are told to find the ratio of old area to new area. Who can take us through that one?
Teacher, can I?
Yeah, who is that one?
Yes, Dav again.
Dav, where gonna? Okay, Dav. It's okay. Dav.
First we find the old area.
This is Roman 2. So we
first find the old area of which the sides are 18 centimeters by 12 centimeters. Therefore, the length is 18 and the width is 12. So finding
what is the formula for getting area down over rectangle?
So finding area is times width. Therefore, it would be 18 centimeters times 12 centimeters. Then use the method, and then later on you get 216 centimeters squared.
Okay. Mr. Secretary, have you confirmed that multiplication?
Yes, please.
Have you confirmed that multiplication?
Yes.
18 times 12. That we go to new area. So
the new area shall be length times width also, and then to be 45 centimeters times 30 centimeters. Therefore, the answer will be 1,350 centimeters squared.
1,350
squared centimeters.
Centimeters squared.
Yeah. So since we want to reduce,
First, wait, I want Mr. Sakaita to confirm those values.
Okay, teacher.
Mr. Sakaita.
Mr. Matumbe is correct.
It's correct.
Who is that? Okay, both are correct.
Yes, they are correct.
Okay, very fine. So that will continue.
We continue since we want to find old area to new area. It will be 216 centimeters squared divided by 1,350 centimeters squared. So I think I find a number that could reduce them that was high, so I divided them both by 2. Therefore, I got 675 on the side of the 1,350 and then 108. So it will be 108 to 675. Teacher, did you hear me?
The big number is 54.
Teacher, I got 108 to 6.
You are dividing both by?
I divided both by 2.
What are you? So here by 2. So what do you have?
Yeah. There. 108.
108, and then here by 2.
I got 675.
Okay. Do we have any other number that can divide both?
Teacher, I didn't get another number though. I think someone else can continue.
3.
Excuse me, teacher.
Can 3 do it?
Okay,
Yes.
let's
Teacher, you can do it.
By 3 here, what do you get?
36.
Get 36.
36 by 3 here.
225.
225. Okay. Do we have another number that can do it?
3.
There is no other number.
There's 3 again. By 3 is 12.
9.
9 is 12.
By 3, what do we have here?
12.
Okay. By 3 here?
75.
75.
75.
By 3 again.
By 3 again, very good.
It will be 6. 4.
That's 4.
By 3 here?
25.
25.
Do we have another one?
No.
Okay. So our final answer is
4 to 25.
4 to 25. Thank you, Dal. And there is someone who completed it.
That you good, Cynthia.
Yes,
Thank you.
Cynthia, thank you.
You're welcome.
So people, I hope this is very okay to everyone.
Yes.
Ratios are written in the simplest form. So you simplify up to this. This is the simplest form. And then the other thing you have to note here is that the ratio 4 to 25 is not the same as 25 to 4, by the way. If you are told to find the ratio of old area to new area, you don't start with new area and then old area. It must be what they have told you to find in the question. So it is old area to new area. And our final answer is to 25. To 25 is the same as friend. If it is the 4 to 25 is different from 25 to 4. We said that ratios are fractions. Now, if you are saying that this is the same as 25 to 4, tell me whether 4 out of 25 is equal to 25 out of 4. Are they the same?
No.
No. So you mind about the order. The order matters. If it is 4 to 25, it must be 4 to 20 what? To 25, not the other way around. Yeah. Okay. So people, I think we can stop here.
Thank you, teacher.
If there are no other questions, if the questions are there, I can answer one. Two.
Thank you, teacher. God bless you. Bye.
So everyone is fine with what we have discussed?
Yes, teacher.
That's very fine.
Teacher, you go through.
Yeah, someone has a request.
So I didn't go through the numbers they sent in the Google Classroom.
The numbers.
No.
Mrs. Nampaj and Mrs. Sambu told you that part. So my work was to send you more practicing questions. Which
Then how will we know we passed?
How do you know you passed?
Yes.
Okay. I'll request Mrs. Nampaj to go through that first tomorrow before she goes to comparing ratios.
Okay. Thank you, teacher.
Thank you, teacher.
Have a very good day.
Have a good day. Thank you, teacher.
Bye, teacher.
Thank you.
Thank